Alright, let's have a look at problem 1647, minimum deletions to make character frequencies unique. So for this problem, we're going to share a set and a check solution. So first I'll look at the statement of the problem, and then we analyze the idea and the procedure, and finally we share the short code. So the statement of the problem is as follows. A string S is called good if there are no two different characters in S have the same frequency. So given a string S, so we are required to return the minimum number of characters we need to delete to make S good. So here actually the operations allowed is the key for this problem. So we are only allowed to delete characters. So that's one point to be noticed. So here are several examples. So we'll look at the example 2. So example 1 is sort of trivial because A appears twice and B appears once. So we do not need any deletions. So in example 2, both A and B appear 3 times and C appear twice. So we can do the following as explained by the problem. We can delete 2 B's. So B appears once, A appears 3 times, and C appears twice. Or we can delete 1B, 1C. So this is another strategy. Or we can delete 2A, right? Or we can delete 1A and 1C. So this is the fourth way. So in other words, the ways to get the final string good is are not unique, right? So so that's basically the examples of this problem. So the constraints about this problem is that S has length greater or equal than 1, means not empty, and less or equal than 10 to the power 5th. This means that we cannot try all possibilities and then choose the minimum deletions to return the result. So the second one is that S contains only lowercase English letters. So that's sort of a standard assumption. So now let's look at the problem or the solution. So here again we're going to use the set and check method. So actually this problem, after we do the analysis, it's an extension of the classic two-sum problem. So the procedure for this problem is as follows. So essentially I will describe it might be a greedy method here. So first I'll count the frequency of unique characters in S and sort these frequencies from high to low. So this is the one step. And then I will use a set, say I call it thin, to indicate that I want to track the frequencies I have already seen when I traverse the list. So then I'm going to linear traverse the frequency list. So at each frequency, if it's already in the set thin, I'll decrement it until it's not in thin. Then I will add the decrement amount to the result, and finally we return the result. So let's look at one example, which is cooked up from example 2. So in example 2 we have ABC, but here we have ABCX. So we have 3 A's and 4 X, 3 B's and 2 C's. So the return is 2 in this case. The counts or the frequencies for the characters A appears 3 times, B appears 3 times, C appears twice, and X appears twice. So the frequency after sort are as follows: 4, 3, 3, 2. Then basically we run the above procedure. So you can imagine if we solve the two-sum problem using the set and check, is the same procedure. So we initialize the result to be 0 and set sin to be empty at the very beginning. So when we look at the first frequency, that is 4. So we didn't. This does not lie in sin. So we update it. We add this frequency to sin. The result remains the same. That is 0. Then we look at second frequency at I equals 1. That is 3. 3 is also not in sin. We're going to put this element in the sin. So we get 3 and 4. The result remains the same. Then we examine the third frequency, that is 3 again. So in other words, 3 is already in sin. Then we are going to continuously decrement this 3 until after decrement the number does not in sin. So we decrement 3 to 2. So 2 is not in sin. Then we are going to update. So we have the sin to be 4, 3, 2. And the result is going to be incremented by the decrement amount. That is 3 minus 2, that is 1. So 0 plus 1 equals 1. So when we look at I equals 3, so the frequency is 2. It's already in sin. Then we continuously decrement the frequency 2 until it's not in sin. So we decrement 2 to 1. So 1 is not in sin. Then we are going to update the set to be 4, 3, 2, 1 by adding 1. The result is incremented by this 1. So 1 plus 1 is 2. So finally we return 2. So with that said, we made it clear the idea and the procedure. So before we write the code, so it's recommended that we look at other problems that can be solved using set or dictionary and check or update method. You can check out other Leetcode videos along the same line. So next we're going to share the code. So the code actually is short and the logic is very routine or simple. So first I'm going to make some preparations. I will track all the frequencies of unique characters. I'll call it count. I'll use this library collections. I'll call it counter. So otherwise we can count from scratch using a dictionary. So this is the first step. Then I'm going to do the sort. So sorted. We'll sort the frequencies, that is the values of the count dictionary. So I'm going to use reverse. Reverse equals true. So I'm sorting the frequencies from high to low. So with that said, let's look at second part. I want to do some initialization. One is the sin, which is a set, right, which stores previous sin frequencies. So another one is a result, whose final state is what we want to return. So now the third step basically is runs above procedure. That is, I will traverse the frequency list, not traversing S. So we do the set and check operation. So for frequency in the auxiliary list, what we want to do is we check if frequency in sin or not. If it's not in sin, so that's good. So we are going to add this frequency in sin, and then we continue, right? So this is one case. Otherwise, we're going to decrement the current frequency to an extent that the result does not in sin. So what we do basically, because we continuous decrement, essentially it's a while loop, while frequency, and in other words, frequency is greater than 0, right? So we while frequency greater than 0 and frequency in sin, then we'll continue decrement that. So frequency decrement by 1. Each time we decrement the frequency, we're going to make one deletion. So we increment the result by 1. So once this done, so there are two possibilities. Either frequency is 0, right? It does not, the whole unique character is deleted. And the second is the frequency is not in thing, right? If the latter case, in other words, if frequency is greater than 0, so it means that frequency is not in thing. We're going to update the thing by adding the frequency state after decrement, right? So once this is done, so we are ready to do the return. So let's return the result. So return result. So that's basically the whole code. We do preparations to get the frequencies of unique characters. Then we sort the frequencies from high to low. Then we use a set to track the previous scene frequencies, and we do the traversal. So if the frequency is in scene, we are going to continuously decrement the frequency and update correspondingly the result. So afterwards, we shouldn't forget to add the state of frequency after decrement into the set. And finally, we return the result. So let's first do the check for this. Let's do a check anyway. So this will pass this one. Let's check example 2. It passes example 2. Let's check our example case. Yeah, it passes this one. So I guess now let's check for a generic case. It passes the generic case. So that's about it for this problem. Before we end, so it's still recommended that we look at all the videos in this series that use set or dictionary and update or check method. So you'll find that this simple method can solve quite a large number of problems. With that said, I guess that's about it. Thank you very much.